Hey guys, I will be sharing with you some ideas, some methods, some strategies or concepts that you can incorporate as you prepare for your final exams, be it you're studying for your mathematics N1, your N2 or your N3. Now, if these videos are handy and you are benefiting from them, you can actually press the like button, or if you've got some ideas, you can leave some comments below. If you also like to be notified of extra videos every time we post them, you can subscribe to our channel.
Now, in this video, what I want to do is show you how we go about sketching cubic graphs. And I'm assuming that you're already familiar with the two basic graphs, y equals x cubed and the graph of y equals minus x cubed. I'm not going to be looking at these as such. I'm going to be looking at sketching more complicated ones, something like these. Now I'm going to run through these two examples, and then I'm going to encourage you to pause the video and have a go at these two graphs. They show off more features that we'll discuss later. But before we start, let's go back to these two graphs and look at one very important feature. So if you look at the graph of y equals x cubed, or in fact 2x cubed, 3x cubed and so on, any positive value of x cubed, one feature that always is the case is that if you go to the furthest point on the left, as we start to move from left to right, the curve increases, okay? It comes in going upwards. Whereas if you have a negative x cubed graph, even minus 2x cubed, minus 3x cubed and so on, what would happen is if you went to the far left here, you'd notice that the curve started to decrease as we move from left to right. And this point we use when it comes to sketching any of these graphs. The first thing I would do is look at what type of term we've got for x cubed. Is it a positive x cubed or is it going to be a negative x cubed term? So with this first one here, I notice that if we take x times x times x, we're going to get x cubed in the expansion, a positive x cubed then. So what we've got then is that this is going to be x cubed, and there'll be other terms as well in the expansions. There'll be an x squared type term, an x term, and a constant, but we won't worry about those. There'll be just plus and so on other terms. So already I know that my curve will be starting to come up like this. Let's draw some axes next and then start to build on this. So if I sketch my axes, got the x-axis, the y-axis, then the next thing I'd want to look at is where it crosses the x-axis. This is when y equals 0. And if y equals 0, because this is factorized, it's very easy to see where it crosses the x-axis. We just know that each of these factors would equal 0. So for instance, if x minus 2 equals 0, x would have to equal 2. So it would cross the x-axis at, say, 2 here. If this factor, x plus 3, was 0, then x would be minus 3. So it would cross the x-axis down here, say, at minus 3. And last factor, x minus 1, if that was to be 0, x would equal 1. So it would cross here at x equals 1. And another useful thing to do is to see where the curve crosses the y-axis, and this will be when x is 0. When x is 0, this factor here would be minus 2, this would be 3, and this would be minus 1. So it would have minus 2 times 3 times minus 1. Minus 2 times 3 is minus 6, times minus 1 is plus 6. So it's going to cross the y-axis here at 6. So I'll just mark that one in then as being 6. So we should be able to draw the curve in now. I know that it's going to start to come up from the bottom here. So the curve is going to come up through the minus 3. It's going to pass through the 6, come down through the 1, and then back up through the 2. Now that's all very well, but I often see some common mistakes made. The first mistake is to draw something like this, where students come up through the -3, go up to the 6, back down through the 1, and then up through the 2. And that would be a common mistake. Why? Well, it looks like the highest point is this point where it crosses the y-axis at 6. It's not going to be the case. The curve will always tend to peak round about the midpoint, not exactly the midpoint, but the midpoint of this width here. So it's going to peak somewhere round about here. So what that means is that the curve is going to come up through the -3, peak somewhere between -3 and 1, okay, roughly around the middle. It's going to rise higher than the 6, drop back down through the 6, head down towards the 1, then turn smoothly round through the 2 and then back out again. Okay, so let's remove the first curve, and so we're left with this kind of curve for that graph. Now another common mistake that I often see is on the ends here. It's quite common to see something like this, people coming in like that, and when they come through, say, this end, they go like that. It doesn't swing out like this, okay? And bending round in this direction. It doesn't bend round so it goes like this, okay? Or this one doesn't bend round so it heads in towards the y-axis. It's just coming out in between this type of curve and this type of curve. Same here. Okay, so don't make these tail ends curve off or curve in, okay, like that. So if we just remove that, that's the type of curve you're aiming to draw. Now when it comes on to this next graph, y equals x times 4 minus x times 2 plus x, then again I'll be looking to expand this out, looking at the x cubed term. We're going to have x times minus x, that's going to be minus x squared, times a positive x, so it's going to be minus an x cubed. So I know that it's going to be decreasing at the start, okay, coming down. So if we draw the axes, let's say we have our y-axis there and x-axis there, just label these x and y, and we've got that this is going to turn out then to be a negative x cubed, and so on kind of graph. Now where does it cross the x-axis? That's when y is 0, and when y is 0, either x will be 0 or this factor would be 0, that means that x would be equal to 4, or this factor would be 0, that means x would be minus 2. So it's going to cross the x-axis then at 0, the origin, at 4, so mark that on as 4, and at minus 2, so we'll take that as minus 2. And where does it cross the y-axis? Well, that's when x is 0. But when x is 0, we can see that this makes y 0 at the origin. So it's a curve then, remember, that starts to descend when we go to the far left. So it's going to come down then through the minus 2, bottom off somewhere between minus 2 and 0, not the midpoint necessarily at all, up through the origin, peaks now somewhere between 0 and 4, roughly around the middle, comes back down through the 4 and then carries on like that. Notice the curve does not swing out like that or curve in, okay, at this end point. And the same with this one, it doesn't go like that round and it doesn't shoot off in that direction, it just goes on like that. So I hope that's given you some idea on that one. Now I did say that I'd encourage you to have a go at these two here. They show off not only these points but some other points as well. So do have a go at these. Just pause the video for a moment, and when you come back I'll take you through the solutions. Okay, welcome back then. So for this one here, first of all, let's see what we get as far as the x cubed term goes. We're going to have 2x for this one, unlike we've had in these other examples, x's. 2x times minus x times x. So it's going to be 2x times minus x, which is minus 2x squared, times this x is going to be minus 2x cubed. So there'll be other terms as well, so it'll be plus and so on. But we've got a negative x cubed graph, so we know it's going to look something like this, coming downwards at the start. As for where it crosses the x-axis, this will be where each of these factors equals 0. So when it's 2x plus 1 that equals 0, you're going to end up with x equaling minus a half. For this one, 2 minus x equaling 0, x would be 2, and for this one, x minus 3 equaling 0, x would equal 3. So it crosses at minus a half, 2 and 3 on the x-axis. So if I draw those axes, you're going to have minus half, 2 and 3 then marked on. Where does it cross the y-axis? Well, that's when x equals 0. And when x equals 0, you're going to get 1 here multiplied by 2 multiplied by minus 3. So 1 times 2 is 2 times minus 3 is going to be minus 6. So mark that point on there as, say, minus 6. So our graph has got to come in like this. It's got to come in down through the minus half, down through the minus 6, dropped lower and turn round somewhere roughly around the middle of minus a half and 2. Come up through the 2, peak somewhere between the 2 and 3, round about the middle, and then drop away. And if you sketch that in, it should look something like that. Well, that's that one. So how about this next one here? I picked this one because we've got this x minus 2 all squared. We haven't had one of these, what we call repeated factors, in any of the examples here. But first of all, I'd want to find out whether it's a positive x cubed or negative x cubed. And we can do that just by expanding this. This bracket here is going to be x times x, which will be x squared, times this x, which will be positive x cubed. And there'll be other terms there then. So what about where it crosses the x-axis? That's when y is 0. So that would lead to x equaling 1. And for this repeated factor, x would have to equal 2. So mark those points on our axes, 1 and 2. And where does it cross the y-axis? Well, that's when x is 0, so you're going to have minus 1 here multiplied with minus 2 all squared. So minus 2 all squared is 4, multiplied with minus 1, that's going to be minus 4. So mark in minus 4, say there. Now this curve is a positive x cubed curve, so we know it's going to rise from the left here. So it's going to come up through the minus 4, go up through the 1, and then it's going to peak somewhere between the 1 and 2 and drop away down. Now what we've got here is that it doesn't cross the x-axis, it turns again on 2. That's because we've got this repeated factor here. Whenever you get repeated factors, you always get a turning effect and not crossing the x-axis. So we're going to have the curve turning at this 2 and carrying on up, something like this. So thanks for listening, and I hope that's given you some idea then on how we can go about sketching cubic graphs.
I hope the video that you just watched was of benefit to you, and as I said, if you benefited from the video, you can press the like button or you can leave us a comment below. And if you want to be notified of these videos, you can always subscribe to our channel.